Next, let's use real data this time, slightly more advanced one. So let me add code over here. Okay, slightly advanced model. So this time, we will also generate graph. So let's, of course, import numpy first, numpy, s, and p. Okay, and then to generate graph, import matplot library dot pyplot as plt. Okay, this library, this particular module, we call plt. And then again, well, we import linear model. So from sklearn, import linear model, import linear model. And then there is a default data set. So let's import the data set as well. There are some data sets. And then some regression metrics from sklearn dot metrics. And then we are going to import some regression metrics that are mean squared error and R2 R squared. So R2 square and then mean squared error. Okay, we will also import those things. And then to make a pretty graph, and then we have a plt style dot use, and then let's do something pretty like a seaborn. Okay, done. And then now let's load the data set. And then let's load diabetes data. So data set dot load. Okay, we are gonna load the name of the data set is diabetes. Okay, we load this data set, and then we are gonna return x and y, both of them, and true. Okay. Load data set. Oh, okay. And then x and y. For y, we will call as a diabetes x, and diabetes y. I think now it works. Diabetes y, x and y. True is not defined. Okay, it should be the capital letter. So diabetes x, diabetes y is from this one. Okay, so let me check the data set. Diabetes dash x. So x data look like this. So okay. Okay. This is so it is a MP library, so that's fine. That's fine. Okay. So now well, we can use many features, but well, to make matter simple, so out of this one, we will use only, okay, we will use every rows, but we will use only second one. And then let me see. Okay, so we have only one line. It is for illustration. And then now we are gonna split the data. Okay, so this part is load diabetes data, and then we use only one feature for practice. And then now we split the data into what? Into training and test set. Training and test set. Training, in the training set, we estimate the model. And then in the test set, we will test whether our model is working or not, basically. So we will define train and then type test. Okay. And then let's use okay. Let's use from the first to the except the last 21. And then test set is from last 20 to the end. Okay. And then now target, we split also the target data, and then basically same target. So target y, and then y. Okay. Okay. So far so good. Now, as we did before, we will undertake linear regression. So first create linear regression model. So this part is the same as before. So regression is what? Same as before. So, well, now, yeah, we import only skleron. So we have to write down linear model dot, and then linear regression, of course, right? Linear regression. And then linear regression. And then, of course, we have to do, we have to fit, okay, fit, but this is too long. So let me separate out two parts. So we regression model. So next, training the model. So now regression, we are gonna fit, okay. When we are fitting, right, we are using the training set, right? So we use diabetes X training set in order to predict this target data Y train. Okay. Okay, so we are basically, so training it is successfully done. Okay. And then now basically we, of course, we can see the regression coefficient. So here, regression coefficient looks like this. Okay. So print, this is regression coefficient. Regression coefficient. Okay. Okay, so I can change the line. Regression coefficient. Done. And then, of course, we can also see R2 square, goodness of the fit. Print R squared, and then change the line, and then I'm gonna see the R squared, which is R2 square. Okay, R2 square. Oh, actually, I didn't run the test model, but here R2 square. So let me check this one, R2 square over here, regression score. Okay, in sample, basically in sample, copy, in sample. So it is in sample R squared, and then it is the training. Okay. So we can see in sample R squared, it is not that high. Okay, it is in sample. Okay, in sample R squared is 33%. Not that particularly high. Okay. Well, it is practice, so I think it is fine as a practice. So now let's test. So we only use training set. So now prediction. Let's predict using the test set. So let us do prediction using the test set. So we will do now y, and now we will define new variable, which is the underbar predict. Okay, prediction. Too long. Prediction. Now we will do predict, and then we will predict one with this test data. Okay, so we will gonna see whether the model predict, the model performs, the model predict the y test set well using the x test set data. Okay, so mean squared error. Okay, first let's print now outsample R squared. Outsample R squared is, of course, now the R squared R2 score. And then, of course, we compare our test set, the real data, Y test set, and then our predicted data. Where is the, okay, type is Y prediction. So our sample R square is actually very high. It's even higher than in sample. So our model can explain 47% of variation of the test set. Okay, so this prediction can explain 47% of the variation. Why? That's actually higher than the in-sample R square. This is not usually the case. This is kind of rare. And then, of course, we can also check the mean squared error. Print mean squared error. Change the line, and then mean squared error. Okay, mean squared error. And again, we compare the test and prediction. This one. Okay, so mean squared error looks like this. Okay. Now, if you are interested what is exactly the mean squared error, R square, and those things, of course you can Google it. I will explain it later. Okay. And then let's generate graph. So let's add a code now. About code, and then let's plot. Let us plot the output. Let's plot output. So first, scatter plot. So let's compare scatter plot between the test set. So PLT scatter plot between, we are more interested in here. Let's compare the test set. So diabetes test, diabetes Y test. And it looks like the scatter plot. So x-axis is the text that and y, the relationship. Okay. And here, color is, let's say, blue is currently it is blue. Okay, almost blue, but yeah, blue. And then let's add a line. Now we can add a line between given the test. I wanna see the y prediction. What was my prediction? Okay, it is blue. Let me change this one into the red. Sky blue, this one. So the sky blue is my prediction. So, and then blue one is a real value. Okay, to make it looks better. So let me make a plot. So it is line. It is much better. And then let's make it sky blue like red. Okay, this looks better. So given the X values, I can make a prediction. My prediction is red, but the real data is blue. Okay, but and they are well qualitative same direction. And then R square is like 47%. So there are some variations like like 50, 30% of variation. Actually, I can explain, but they are the fine. Let me make it line. Let me make it a bit. Okay, now it is the thicker. So there are some variation I cannot explain, but it is qualitatively quite reasonable. The less, okay, so it is always a good idea, like to PLT show. It is always a good idea to show this one, put this one, okay. Here it is optional. Well, actually we don't need these numbers in x-axis and y-axis, not exactly. So, well, let me delete PLT, y tick, y tick. Okay, so I delete y ticks and then let's delete PLT, x ticks. Okay, good. So this was regression using the default data, which is actually real data.